Hey, so for this problem, I should first question, which asks for the probability that x2 equals to 1. And so this is my answer here. So my idea is that there are two cases when x2 can equals to 1. That is when x1 equals to 0, given x1 equals to 0 and x2 equals to 1, and given x1 is 1 and x2 equals to 1. So I just need to solve the probability of these two parts and combine them. It should be the final result. So for the probability of p x2 equals to 1 given x1 equals to 0 should be 0.4 times 0.2, which is the probability of x1 equals to 0, which is 0.2 times the probability that given x1 is 0, x2 equals to 1, which is 0.4. And similarly, the probability of x1 equals to 1 is 0.8, so 0.8 times 0.7 should be this parts. And when I add up them together, I got 0.64, which is the probability of x2 equals to 1. And similarly for part B, which asks for the probability of x3 equals to 1. It is, I think it's like add on to the first question, and I can like write it in matrix form, but also like just I prefer like write them similarly to part A. Like it the probability of x3 equals to 1 is given x2 equals to 1, probability of x3 equals to 1 plus when x2 equals to 2, x3 equals to 1. So for I have already get the probability that x2 equals to 1, which is 0.64, so I can use it here and also use the given formula here, which is 0.7 when xk equals to 1. Here xk equals to 2 and k plus 1 is 3. And for this part, as I know, 0.64 is the probability of x2 equals to 1. So the probability that x2 equals to 0 should be 0.36, which is 1 minus 0.64. And it times 0.4, which is this part. So I can get 0.592 as the final result for x3 equals to 1. For part 3, which asks for given x3 equals to 1 and find the probability of x1 equals to 0. So for this question, I use the formula of conditional probability. Like we know that given x3 equals to 1, find the probability of x1 equals to 0 equals to if these two events happen together over the probability of x3 equals to 1. And this form can also change to this form, which is like given x1 equals to 0, find the probability of x3 equals to 1 times the probability of x1 equals to 0. So these are really similar formulas, just like if I times p this part here, then I get similar for this one. Yeah, it's like if I also times it here, then I got a similar formula for this one. So I get 0.6 times, so for this part, given x1 equals to 0, the probability of x3 equals to 1 is 0.6 times 0.4, because I already know that xy equals to 0. So I just need to calculate the probability of x2 and then derivative of x3. So given it is given xy is 0, x2 can be x2 equals to 1 is the probability of 0.4 times 0.6, and this is the probability that x2 is 0 and x3 equals to no, it should be like x2 equals to 0 and x3 get 1, which is 0.6 times 0.4, and also x2 can be 1, so it should be 0.7 times 0.4 to get x3 and x2 both equals to 1. And then the probability of xy equals to 0 is 0.2, so I type 0.2 and over probability of x3 equals to 1, which is 0.592, which I get in part B. And so for D, I need to find the limit of probability of xn equals to 0 as n goes to infinity. So for this question, I write the problem according to the clue the professor gives. So we know that actually, there should be n here. So it's like A should be the probability of the probability of, oh yeah, it should be like for here it's always changing for x1 equals to, so in the base case it is 0.2 and x1 equals to 1 is 0.8, but over the time it is changing. So I just use A to symbol that. And according to the formula, I can write it in matrix that for the xn equals to 0, it should be A times 0.6 plus 1 minus A times 0.3. This is similar to what I tried to do here. So because we know that A times 0.6 plus 1 minus A times 0.3 should equals to A, which is the probability of getting 0. So from this formula, we can get A equals to 3/7 and get 1 minus A 4/7, which is the probability of xn equals to 0 as n goes to infinity.